Great. So yes, today we're going to be talking about a subject that's really a passion for me, that's hay. So I'm Nadine Bessonen, I'm the co-founder and CEO of Quantori, and well, maybe I have like something a little bit special, but I do love hay. I don't know if that's the fact that I was born in July, maybe like at the time of the hay season, but I was born and raised on the farm, and the dairy farm where hay was really the main feed of the animals. So maybe my passion for hay came from that. And I hope that today I can, also like convey this passion to you and give you a little bit more insight about hay and maybe about like how to monitor hay 24/7 so that we can keep the best quality out of it and, to make our cows happy. So Quantori by itself, so Quantori is a Finnish company. I don't know if you know where Finland is. I would say that if I look right next to the window, right through the window right now, then it's snowing. So that's how Finland is. It's famous for like Santa Claus, but it's mainly famous for being one of the most Nordic countries in the world. So you might be wondering, like why on earth, like are we, talking about hay when we come from Finland? Well, the truth is that so hay has always been like well important for obviously for Finnish farmers, and from already like a century ago, we really tried to see how to preserve hay. So since in the Nordic countries it's really moist, there's a lot of water, that's not easy to dry hay. So if you have heard about like what's called AIV fodder, that was invented in Finland, and that's by someone called Arturi Virtanen, and that was back in 1929. He even got the Nobel Prize for chemistry in 1945 for inventing this preservative for keeping hay in the good condition. So that was really for the preservation methods that he got even a Nobel Prize on that. So just to tell you that, you might be from the Nordic countries, but yet, like facing the same issues and looking at how to preserve hay in the right quality, in the right conditions. So Finland, so the Quantori is based in Finland. It's like we are a new company that founded in 2016, and we are providing different type of monitoring solutions for any type of bulk store materials. So when we talk about bulk store materials, that's not really sexy. That's what I tell my kids. That's everything that's stinky, scratchy, and itchy. So that goes from hay, which we're going to be talking today, any type of byproducts like cotton seeds, almond hulls, you name it. Then also we have grain, any type of seeds, side streams, commodities, and biowaste. So we really do have a system that monitors all these organic materials to prevent them from getting bad. We are located, so headquarters are in Finland, but we do have different subsidiaries, and one of them is in US and it's in California. So if if some of you are like from California today, so hi to the same, it's the same state. We have like over 2,500 customers in 30 different countries, and some of the countries are even Tahiti, where some of our workers really would like to go and visit our customers there. But unfortunately, our systems are plug and play, so no need to go to Tahiti to install it, unfortunately. But so let's focus on what brings us today. That's hay. So, hay is the main fodder for dairies, for most of the animals. And I would say that hay is quite precious. And what I've learned from the US is that, like hay is also called different names. It's called the green gold. And I think it tells quite well its name, green gold. Well, it's green, just like hay, but gold also because of the fact that hay is really precious. And what we have seen over the years is that even the price for hay, or like the availability of hay, price for hay has gone up because of availability of hay. That's more and more difficult, to get like more cuttings. Like in some places where you would have previously 3 cuttings, now you're maybe down to only 2 because of lack of water, because of this, climate conditions that are changing. that makes so that, you know, hay might not growing as much as it used to be. So as a result, like there's almost, I wouldn't say like a shortage of hay on the market, but let's say that there's quite a big competition of like getting this hay available for dairy farmers themselves. You know, there's like a lot of export of hay in China, in Japan, in the Middle East, South Korea. So there's all this kind of tension on the markets on almost like who will get hay for himself. So that's quite interesting to see, like, you know, that that hay is this green gold, like globally. And obviously, like if it's a gold part, then, you know, you need like all our purpose and our mission in at Contour is to make sure that this green gold, you know, keeps its value. So its value on different ways, value that it doesn't get bad and that you don't lose it completely. And as I said, like green gold, because it's the main feed of the dairies. So it brings like what does the dairy needs? Like a dairy cow like needs different things. You know, it needs fibers for like its the proper functioning of its rumen. You know, like for all the rumination. So like all the fibers really comes mainly from hay and comes from grass, from straw and silage. That's one part why hay is important. Another thing is that cows need obviously some energy. So the energy that you're gonna get from this carbohydrate, the sugars that's inside the feed, that's you will find that inside hay, and that's called this TDN, the total digestible nutrients. And then obviously you have the crude protein, the CP, that are really crucial part for like breeding, lactation, and growth and well-being of the cows. So right now, dairy farmers, where do they get the crude protein? Well, you can get them from some hay, obviously, but you can also get them some concentrates, cereals, byproducts. You know, you can find this corn gluten, beet pulp, and all these proteins, like, as you know, that concentrates are quite expensive. Raw materials are expensive, so dairy farmers have been looking at other ways to, or like maybe like more cost-efficient ways to not to depend as much on these proteins, which is called these protein dependencies. And when over in Europe, we will be emphasizing more like on byproduct to compensate for proteins like this corn gluten and this beet pulp. Like in the US, you know, you have like some quite interesting things that we don't have in Europe, like for example, cotton seeds, which are full of proteins and fats, but also like these almond rolls that brings also proteins to the dairies. But now like the hay itself. So as I said, like main feed for dairies, and I don't know if any of you has ever really looked with a magnifier like how hay looks like. Well, if you are taking like magnifiers and was really looking at in details hay, then you would be seeing that these little teeny little things that they look cute on the picture, but they are not so nice in how they affect hay, and they are called these fungi. So fungi is a little bit like a mushrooms in a way. They are bacteria. And these bacteria, they are always inside hay. They are always present in the cut hay. Whatever you do, you will not be able to get rid of them. And these bacteria, they are like silent contamination of hay. So they don't say anything, but well, I would say that they really like attack hay. So once we, let's say that there's the cutting, and then we are like mowing hay, and then also like baling hay. So what's going to happen inside the hay bale, right after baling, then you will have what's called respiration of hay. And over in Europe, and if you are like in Switzerland, the Swiss guy, they say that hay is barfing. And I'm sorry for the expression, but it's not exactly like really like the most polite expression, but this hay is barfing really represents exactly what hay is, how it's behaving. So this hay is this respiration, then it's going to be freeing some CO2, some water, and some heat. So that's why, like after baling, you will always see like an increase of temperature inside your hay bale at first, and that's kind of like the normal way. And if everything's fine, then the temperature is going to go down. So like you will see like this line, dotted line, temperature is going down, everything's fine. But however, if you have still some moisture inside the hay, then all these little fungi, they're gonna love it. What they're gonna be doing is that at first we'll have a reaction called an aerobic reaction, where these fungi are gonna be consuming the carbohydrates. They're gonna be using, you know, all the oxygen that's present around them to populate. So they will be freeing some gas and some heat. Once there's no more oxygen, there's going to be an anaerobic reaction happening where these little fungi, they don't need any more oxygen to live and to populate. So it's going to be like this rippling effects with even exponential effect where all these fungi are just going to be like increasing really a lot, releasing heat, gas, and more heat and more gas. So at the end, what do we have? So we have fungi that are enable or like that they like moisture, and then they have carbohydrate, which are the sugar of the hay, and these will be releasing heat, gas, and what do you miss? This is called the triangle of chemistry: heat, gas, and oxygen, and then you have fire. And I don't know if you know, like, where the oxygen can come from, you know, it can be really small hole made by a mouse. We've seen that, you know, like you have like your haystack, that's inside the haystack, you have extremely hot with some gas, then a small mouse is coming through the haystack, bringing some oxygen from outside, and poof, then you have what's called these hay fires. And interestingly is that so many things that the hay fire can happen only weeks of after baling, but that's not true actually. Like it could go up to 6 months after baling, and there are some studies about that shows that, you know, you are not immune of hay fires after like 1 month or like after a couple of weeks. You should still be doing monitoring as long as the hay is pretty much fed. Hay fires can happen inside hay bale, inside the round bale, inside the square bales, and have more like risk if like the bales are really dense, and they are likely to happen within the center of the bales. And something that I would like to insist, and I know that's because, you know, the origin of the company comes from my brother who lost the whole farm due to hay fire. So, you know, I'm quite sensitive to this subject, but what I want to say is that the risk zero does not exist. And it's not, having a hay fire is not due to bad practices. It's like, you know, there are a lot of parameters to take into consideration. So many parameters that the farmer doesn't necessarily like handle all of them. And this causes like can come from different like origins. First one is that production, and that's the first one always that farmers are like thinking of. So, you know, like you haven't cured the hay enough on the field, you've baled hay too early, so that the moisture content was still a little bit too high, or there's been rainy episodes during the curing of the field. You know, everyone knows what's happening. You know, like you look at the weather forecast, they say that, hey, it's going to be raining in the next 2 hours, then, you know, you rush to bale hay, and then, so that's things like that can happen. There are so many parameters at production that it's not easy to handle all of them. But this, I would say, these parameters, like often farmers know about them and try to mitigate them as much as possible, which is really good. But there are some others, so like causes for hay fires, which are quite often underestimated. Often, like farmers think that, hey, now the hay bales are baled, they were like in good conditions, then nothing more that can happen. But that's not exactly true. Like you have quite many also possibilities of getting a hay fires after production. First one is the ground moisture. So, you know, you put like hay on the soil, and then like if you have like in the morning some kind of humid and wet and maybe like cold as well mornings, that all this moisture can go up and penetrates inside hay, and that can reactivate these little fungi, which gonna be like starting this fermentation process and eventually the hay fire. Inadequate storing, so you have I don't know, I would say that maybe you have holes on the shed, on the roof of the shed, or like if you are using some tarps that are extremely tight on the haystack so that the moisture cannot escape anymore. So that's also like creates these favorable conditions for fungi to repopulate. That's another reason. Transportation going from, I don't know, Idaho to California. So with trucks, might have been some rain on the way. So like a truck that left at moisture content of less than 12% might arrive, like at destination thousands of miles away at, more than 14. So that's also like one cause that of reactivating fermentation. High density bales, nowadays we see even the double compressed bales. So the more compressed the bales are and the more difficult moisture can escape. So that increases also like the risk of fires. And then there's something that's rather new, that comes from like a study that was conducted in Australia, that they showed that in case of like drought, so extreme conditions, it's been really hot, then the plant itself is going to behave in such a way that it's going to protect itself by keeping or like by having really high level of sugar, keeping it for itself instead of like using or like for like the photosynthesis. And this high level of sugar that, like that's a source of fuel for this fungi. So that can have a risk on fermentation of hay. So once again, there are lots of causes that that can trigger a hay fire. So that's why I'm saying that risk zero does not exist, and also that's saying also that there are so many parameters to handle that it's not easy for for a farmer to be immune to hay fires. And that's how, like, as I said, like, like I went through like a hay fire, so I've seen like how devastating this experience can be. Like in one blink of an eye, you basically pretty much you lose everything. So if you lose one haystack, that's fine. But in the case of my brother, that was the whole farm that went on fire. So that's something that stays in mind, and that's obviously quite a trauma. And that's how we decided to come up with a system that that gives you monitoring of hay 24/7. Until now, like you have like this manual probe that that you have to do, as the name is telling itself, it's manual. So you have to go and yourself poke hay or like poke the hay bales that are available to you. But what we wanted to have was like a system that's plug and play. It's based on wireless temperature sensors that I don't know if you see the camera, but they're like the probe is here. Then you put the probe inside the hay bale at the time of stacking hay, and then you just let the probes monitoring hay for yourself. So I have a demo here for you to understand what I'm talking about. So this is pretty much what you have on your smartphone, on your tablet, on your computer. It's a full overview of your site. So for example, here you have 5 haystacks, and all the haystacks are monitored 24/7. And you can see right away if the haystacks are fine, like for example, stack 2 and stack 3, you can see that it's all green, there's no alerts, temperature of hay is just fine. But then in stack 1, for instance, you have like 2 alerts, and then you can see the temperature, the highest temperature over the last week, the tendency, is it going up, is it going down? And you have also like the lowest temperature of the last week. And if I open then this, then the interface, then I can see like, in 3D, what's the behavior of the haystack. So you can see that all these little squares, they represent itself like one individual hay bales. And then you can pinpoint right away where you have some hay hotspots. And then if I open on the hotspot, then I also see what's the temperature trend, and giving me the temperature at every hour. What's happening, is it on the verge of maybe creating a hay fire, or like is it going down? And obviously like once you reach certain level, then you get some alerts on your phone. So that's something that we wanted to bring to farmers was to be able to keep the assets, because hay has like quite some high value. Last year it was close to, in California at least, was close to $500 a ton. So that's again, that's a little bit this green gold. So the value of this haystack is quite high. So preventing losing value, losing the assets for farmers and for dairies. Now, just to let you know, we have for the last more than 5 years of monitoring hay. Out of our customers, if you were taking a pool of 100 customers, then 12 of them would have received at least one alert above 136 degrees Fahrenheit. And the feedback of our customers is always that we did not know that hay could get so hot. It's just like when you look at the haystack, it looks like a green box, and then you have no way of knowing what's happening deep inside. And that's this knowledge that we really wanted to bring to our customers. And really, to our surprise, is that hay ferments much more than what we can even expect. Now, the first point was really on keeping this as asset, this hay. But the second point is, as you know, is the hay quality. So how do we give an indication to farmers that's on what the hay quality is? This is a survey that was done in Quebec, and they were looking at what's the price, the feeding cost for a single cow having producing 15,000 pounds of milk per year, and then giving high quality forage, average quality, and low quality. And you can see right away that the feeding cost, because you have to add concentrates, obviously, if you have not so good quality hay, then how the feeding cost increases with lower quality forage. So what we wanted to bring is what's the quality of hay at time of feed? What's the quality of feed now, or what's the quality of hay now that I speak, basically? It's usually the quality of hay when you store hay, you might be taking a sampling, few samples here and there, and then send it to the lab and get the results and use it for feeding afterwards the cows. But between the time you store hay and the time it's being fed to the animals, this might be several months. It might be 2 months, 6 months, 10 months, sometimes even 1 year. So what has happened to this hay quality between the time you store the hay and the time of feeding? And that's what we wanted to bring to our users. And if I go back to this interface, if I stick back to this haystack where we have 200 bales, we have a function that's called a feed value indicator that tells the user what's the health of each bale. So, for example, you see that this is brown. So brown means obviously that it's not so good. So it means that it has fermented. And if I click on it, then it already tells me that this bale has lost some energy, and it has lost at least 5% of its digestibility, and it's on the proteins, and it's a lot. So based on this knowledge, if I was to take this bale out of a haystack and knowing that, hey, right now it has lost 5% compared to when I stacked it, then I can adapt the feed of my animals so that my dairy cows don't suffer from this loss of energy. So that's the reasoning behind. It's giving the end user a 24/7 information about the quality of hay, and going even beyond, it's giving also prediction on how how it's behaving. So, for example, here I have a bale that has already lost some energy, and telling me that if I don't do anything with that bale, then in the next tomorrow, basically, it's going to be changing category, and it's going to have even more loss of energy. So in this case, if I can take this bale out and give it as feed right away, then I will avoid losing even more energy. So that's a little bit different approach on how to consider the hay. So taking a hay bale from the haystack and then looking at what's the pedigree of this hay bale, like what's the quality at the time of feed, and being able to adjust then the feeding to the animals. And I'll go back to this. So as I said, so two different axes. So the first one is making sure that we keep the assets, the asset before they burn down, and the second one is really to give this feed value indicator, or like giving the hay quality in real time to the end user. And now I'm gonna let Marie continue, because you might be wondering, yes, that's nice, but actually, like, what are the grounds behind, why, how do you explain the results, and how did you explain the model that you came up with? And then Marie can go on and explaining the different pilots that we've had globally.
Yes, thank you, Nadine. Yes, so as agronomist, so part of my job is to follow the different pilot farms that we have been working with for the past 2 years. So I'm going to present you shortly a few results of those pilot phase that fueled our model to predict the right preservation or the degradation actually of the forage quality during the storage. So the experiments that we made in a few key figures, we have been working with 7 farms that were volunteers to carry out the experiments. So we've had farms in Italy, in England, and in France. Overall, 900 bales were monitored continuously just for these experiments, and we have been taking hay samples. So part of the protocol was that we were taking hay samples in the beginning of storage and in the end of storage, and looking at the variations of the nutrients inside of those bales and comparing it with the temperature that were monitored with the HAYTECH probes. Then we were kind of adjusting our models with the theoretical models already existing. And in the end of these experiments, we found an 80% predictability of our model regarding how well the hay was preserved or how it was degraded during the storage. So that was pretty good. So you can go to next slide. Yes. So now I'm going to present to you a few cases that we've had with specific themes during the year 2023, because we found that they were pretty interesting. First, regarding the fire prevention, because it was like the primary goal of the HAYTECH probes. Let me take you to Italy, where the Parmigiano Reggiano is produced. So it's in the northern part of Italy, and in farms where they have special specifications to produce this cheese. So, for example, the cows have to be fed with hay and grass. The use of silage and a lot of concentrates is actually forbidden for the taste of the milk. And so in this farm of about 300 cows, last year was pretty hard, because in spring 2023, the equivalent of 6 months of rain fell in 20 days during the month of May. And so it was almost impossible to dry properly the alfalfa that they were growing to feed their cattle, because the soil was completely soaked in water, and they had barely a few days to bale and cure the bales. So what happened is that they had to store the bales inside their warehouse with a moisture sometimes up to 30%. And that did not miss. What you can see on the screen is that the bales heated really a lot, up to 160 degrees Fahrenheit and sometimes more. And as you can see on the picture, they got completely dark. Thankfully, nothing caught fire because all of those bales were mostly kept outside or at least not piled up. But this also led us to make a bunch of samples on them to kind of track during all this storage period how were the nutrients behaving inside of the bale. And as you can see, the fiber content, so this NDF, is rising really high. So you have, in the end of the storage period, you have up to 70% of fibers. And on the contrary, the crude protein, this CP, is going down to 6%. So you can see that the composition of the hay has been evolving with this temperature trend during the whole storage, and the protein, which is basically what you would want from alfalfa, is going really down. So in the end, the hay is kind of empty to feed to the animals. So the kind of partial conclusion from at least this very case was that the bales did not catch fire, and that was a great victory regarding the situation. And also the hay quality variations were really visible and quantified. But you might think that most of the time the hay is not heating that much. So what is happening when you have some heating, but that is not as obvious as what we saw in Italy? Now let's travel back to the UK to answer this question, where we were working with a company that was that is still actually producing quality horse feed. So what they are doing is that they are collecting mostly alfalfa from local farmers and turning this alfalfa into feed that they sell for horse farms. At this company, we monitored 600 bales that within the experiments you have a picture on the right of the screen. And we mostly observed the bales' behavior regarding their number of cuts, because they were storing their hay, like dividing the first cut, the second cut, and the third cut of alfalfa. And in this case, what we observed is that so the first and second cut were not heating at all. As you can see, the temperature curve stays pretty low. So what the app was showing is that there was no degradation of the quality during the storage. Which means that basically you have the same quality when the bale enters the storage than the quality that from the hay that you are going to feed your animals. So that is a pretty great success for this company, actually. However, for the third cut, because most likely because it was end of December or end of August, beginning of September, it was a bit harder to dry the alfalfa at this period. So as you can see, when the bales were entering the storage, you had a high peak, a high cycle of fermentation, and then it went down pretty fast. So it settled pretty easily. And this kind of trend was visible for some bales, but not every bale. And what we saw with that is that the bales that were heating the most were the ones on the back of the storage, so facing a wall, basically. So maybe there was some issues with the ventilation or something that was preventing the heat to get out of the hay pile, and maybe that's the reason why those bales were degrading faster than the other ones. So this kind of gave us a first view of how a hay that is not heating a lot behaves, but we had actually an even better study case in France where the bales did not heat at all, and you could still see some degradation because we were using a lot of really detailed information. So yeah, as I just said, I'm taking you to France now. In another farm that is producing milk for cheese, but this time no specifications. So it's a basic, it's a typical French farm where they are feeding their cows with corn silage, a bit of hay, a bit of concentrates. They are using mostly shed material that is pretty common in France. And the year 2023 was well, pretty normal, so there was no excessive heating whatsoever. The farmer from this farm had one favorite grassland that we monitored to see a bit what was happening inside of it. Yes, and what we could see actually on the bales from the farmer's favorite grassland was that the bales were a bit heating, but not so much, and they were settling at a certain range of temperature that was not so important, that when you can see the bale at those temperature, when you are inside the storage, they smell the same as good hay, they look the same as good hay, so you don't really see the difference. And so this farmer, because it was his favorite grassland, was keeping this hay as long as possible, so he always has some quality hay for his cows. Now, when he looked at our app, what happened is that 1 month after the storage of the bales from this very grassland, he witnessed a big degradation of the quality predicted by the app, of the quality of those bales. This expected decrease was about 10% or more, and the farmer took actually the decision to feed these bales in priority instead of keeping them a long time, as he was usually doing, because of this warning from the application. And what we did was that we took the samples also, and we compared what was the lab saying compared to what was the application saying. And what the lab said is that, we were kind of right, because so as you can see, the crude protein content, well, did not vary that much. It actually depends on the bales, but also because the crude protein content reflects the whole amount of protein and not just the digestible portion of the protein. So there might have been some changes in terms of digestibility that we cannot see within the crude protein parameter. However, with the fibers, it is pretty obvious that they have been increasing a lot, the proportion. And with the relative feed value, I guess you are familiar with this, but basically it's an indicator that reflects the digestibility and the intake, the easiness for the cow to eat a lot of this hay. As you can see, this RFV is losing 10 points or even 20 points for the second bale without heating so much. So, and this is a lot. So with this model, we have, with this HAYTECH model, HAYTECH system, and with this feed prediction model, we have actually more information on what is happening inside the storage, and this gives time to react. So in emergency situations like we saw in Italy, but also time to act and to make some strategy, like this farmer in France who decided to feed his hay that was degrading first, because he did not want to lose more nutrients inside his storage. However, the bales that are stacked, they are influenced by a lot of parameters that might make them degrade faster or not. And that will be my last story. But with this same French farmer, we had another grassland that we monitored, and as you can see, it's a very small field, so it's pretty homogeneous, that the way that it was baled, the way that it was dealt with. There was no really reason why one bale should behave another way, and one other bale should behave another way. But what happens is that during the storage period, we witnessed on the application that two bales were degrading. They were not heating so much, which is why I did not show you the temperature trend, but they were losing quality. And so when we discussed with the farmer on why this was happening, we went back to all of his field management. And he remembered that when he was baling these fields, he was using a shared baler. And when he started baling, the settings on this baler were the ones from his neighbor. And actually, the 2 first bales that he did were too tight compared to what he was usually doing. So when he did that, then he just baled those 2 bales, and then he changed the settings and everything went back to normal. And when we checked the IDs of the bales that were too tight with the ones that were degrading, those were the same. So we really witnessed and quantified the effect here of the baling density with the right preservation of the hay during the storage. So this led us to consider that also the HAYTECH system can be used as information to put a quantitative impact of your field and the storage practices on the quality of the hay at the end of the storage when you are going to feed it to the animals. So this is actually very interesting, and we are going to push forward to put even more precisions and even more numbers for that with the next pilot phase from next year. And so last but not least, I would like to stress a bit on the importance of forage quality. These are terms that we have been discussing with our pilot farms, like why do you want quality hay in your farms? And as you can see, this list, like there are numerous reasons, and this is not even all of the reasons on this slide. So whether it's for your animal well-being, to reach your targeted yields, in terms of quantity, but also of quality of milk, to ensure good ruminal health. All these things are linked directly with the hay quality, and this is why we really want to work on that.
And well, thank you, Marie. And then when Marie could say, like, she's excited about, getting more and more parameters about hay.
Yeah, I'm very excited.
And now, like the next one, like, we've been talking about feedback new indicator, but what we're gonna be like releasing soon, and that's where we are like improving the model, but it's really like how to give really the full DNA of hay. So, like the CP, NDF, ADF, TDN, and RFV. So as the changes, during the storage time, so that at time of feed, and you have really like a clear characteristic of hay. So we have patents on that. We've been like also like doing some research with European Union. So I would say like to be continued, and it's really exciting results that's gonna come back soon. That's all these results are really based on, as I said, we are like really hay enthusiasts here, like, and having like, as we speak, like 500,000 tons of hay is monitored right now. So it's like globally, so which is great, and giving us like lots of data points to be able to bring even more information about hay and more tangible and more qualitative information, so that you can be access to this information to make much better decision based on data. So please be tuned. It's going to be coming up soon.
Yes. All right. Thank you, Mary and Nadine. That was very well said and a lot of very useful information. Hopefully you guys have gathered some information from them. We have a few minutes left in our webinar. We'd like to use this time to allow or ask for any of you who have any questions. Now's a good time to either click the microphone button or drop a message in the chat, and we can clear up any questions you guys have.
If you open the chat, actually, you'll see that there are a few questions.
Okay. Yes. Will the recording be shared? Yes. So we will be sharing the recording. We will get that to you here quite soon.
Yeah.
Yes. What is the best setup for storing shed? Good ventilation shed or contaminated shed with less ventilation and air circulation? Yeah. Let's see, do we we have?
Although, you know, like I understand that, of course, everyone would like to have good ventilation shed. But there's also the reality. Reality might be that, you know, you don't have really much space. If the best would be that, you know, you have a lot of space and then you can, you know, spread out like haystacks and leave at least 100 feet in between. But the reality is that space might be scarce and then, you know, you have to do the best you can. So that's why, again, like this risk zero cannot just not does not exist.
Could we have an idea about the pricing of the system and what is the business model?
See.
Yes, so ideally we would like to first kind of contact and have a call so we can discuss your setup and kind of some parameters of your farm. Then we can outfit your setup to your likings and best give you a price for that situation.
The next one, how deep does the probe need to reach? So what you need to understand, like if I have this, so these are really like a place, whether you have like, so with large bale, it's fine. So you have the bales and you put it in the bale and then it stays there. So it means that, you know, when the bale is fully buried inside the haystack, then you really have the temperature, you know, deep inside the haystack. And again, like this was designed in such a way that the length is long enough so that it gets the temperature of round bale, square bales, and also large bales. So, and I guess for large bale, you mean, you know, like this really highly compressed bales. Most of our cases in the US are like with large bales.
Yeah, we have someone raising his hand also.
This is Yves from Canada. Just going back to the pricing question, I'm sorry, but I didn't like the answer. It's you know, when we're in front of a customer and we're talking about your product, and then you know, we get him excited and interested. Would it be? I find it very difficult to understand exactly how the whole pricing system works, and to have to go back to you guys to get some pricing, and you will probably have more question. You know, the whole time that we spend here, we're kind of losing the hot lead, if I should say so. So. What's so complicated? That's what I'm trying to.
No, well, it's not really complicated. The easiest way to do is like we have different packages, and you know, like the package that's really for the North America. For North America, it's a package that includes 100 probes. 100 probes. It's all what you need, like a starter pack, all what you need for getting started. And pricing is quite simple. You know, it's $199 per month. So. And that's what we've been selling, honestly. So, but what Kelly meant is that, you know, like depending on how, in a way, what type of coverage you want to have. But what's really the standard really like product is really like a full pack that includes these 100 probes and access to the application, and as well as the what we call a base station, which is the you know, the one that's gonna read the probe and transfer the data to the cloud.
So the recommended coverage, if I understand correctly, is roughly 30 to 40%. Is that correct?
I would say the more the better, but it can be like that. Yes, like some of them are just putting one per pile. You know, like if you have like your whole haystack, and then if you consider the pile that are vertical, then some are putting like in one per pile.
Okay. So the 100 probe, if we assume, let's say like 40% coverage, the 100 probe would cover how big of a stack in total of bales?
Well, you know, that already like even for 10%, then you already like with 100 probes, you already have like 1,000 bales.
Okay.
So, which is already quite significant.
Okay. And did I understand correctly that you're renting the probes, like the customer does not take ownership of the equipment. Is that correct?
Yeah, we have different models, but like that's one model that's a subscription model full year. So that means that we take care of like all the what I say, like the the maintenance of the probe, yes, or the whole system.
Okay. And in terms of the because sometimes the internet is not there's no internet at the farm, so I understand that you have a system also that uses the mobile network. Is that correct?
Yeah, that's correct. So like what's the space station, it has an international SIM card included, and that hooks up on any network. We've tested that in even remote places in Australia where you only have snakes there. So as well as in Canada as well.
Yeah, and if internet is available on the farm, is there a maximum distance from the where we need to put the repeater away from the building, where the nearest building where internet is accessible?
Yeah, so I'll tell you that in feet, where is 1 feet? 50 meters, so like up to 200 feet about between the haystack and the base station on the relay.
Okay, all right, thank you.
And we have a question from Hugo that says, where is the temperature logger located within the probe? Is it in the tip or along the shaft?
In the tip. But obviously, you know, when it's gonna like warm up at the tip, you know, the whole shaft is gonna be also getting warm as well.
Yes.
So there's like this question, 100 probes for 1,000 bales. It's again like depending on what type of coverage you want to have. We do have, so you know, the more probes you have, and then the better kind of like quality indicators you get. We do have customers that with this large bale, they put one probe in between two bales. So that's what we always like advise is like start with like a standard pack of 100, and then you know like base, and that's what Kelly meant a little bit, like just add more probes as it goes.
Yes, and you can actually spread them in a way to make sure that you have a representative view of your stack, because if you assume, for example, that you have a certain amount of field, then if you do, for example, your first cut from one field and your field is like homogeneous somehow, then you can imagine that if you put, I don't know, 10 probes into your field, then you will have a representative value of what is going inside this set of bale, and so on. So if you have fewer probes, then you can spread them a little bit more with strategy for that kind of stuff to see how the bales are behaving and stuff. And then if you want to add more because you see that maybe the information is not complete, then you can complete it using this kind of way of thinking also.
Next question is this price for $199 for 100 probes per month. How many base stations it includes? This will include the first base station or one base station.
Which can be up to much more, many more probes as well. Someone is writing.
Yeah, one more come.
But you know, at the end of the day, like we are really opening up the door to knowing much better like what's happening with hay. Until now, like if you look at the traditional model, is that you take a hay sample, if you do, before hay is stacked, and then you use this value pretty much all the way for like making the feed of your animals. And you know, you're waiting for the animals to produce, then you take like the milk analysis, milk from the milk sample, milk analysis, and then based on this milk analysis, you're gonna be changing the feed of the animal. So this adjustment of the feed really happens after milk is produced. And what we want to bring here is that knowing the hay quality at really at time of feed, and you can adjust before you even feed the animals. So that's something that we want at the end, of really having happy cows and you know, and maintain the milk production. So because over the year, if you take like the lactation period of a cow, then you really see a lot of variations. And some of the variations are really coming from the quality of hay itself. And variations can be really like, you know, 5 to 10%. So that's quite a lot if you start putting that into monetary value of the price of milk. So if we can like really maintain always the same quality and same quantity, and obviously the same quality as well of milk, this is what then we are on the winning side.
Yeah. And so the next question is, what if the moisture and high temperature is far from the probe?
Well, the probe, like the probe was really designed to be able to catch anyway this hotspot. So this hotspot is going to be propagating within this hay bale. And what is for you, Marie? How you predict degradation of RFV?
Well, so the RFV is calculated with the fibers, so this ADF, acid detergent fiber, and NDF, neutral detergent fibers. And those are two parameters that we are studying with the hay samples that we've been doing. So we are studying the variations depending on the temperature and stuff. So then it's just when you know how to predict the NDF degradation and the ADF degradation, then mathematically speaking, you can also predict the RFV degradation. But so we are all of those data that we are doing, because the samples that we have from the labs are also giving us proper RFV value. It's not something that we just calculate manually. So we can also just feed this to our model that is working on this prediction.
So maybe like something to add? Yes.
And no, the sensor doesn't do the measurements in itself. The sensor is just for temperature, and this is why we are building a model fueled with lab samples and the temperature from the probes to build this model of degradation. But we don't have NIR sensors inside the probes.
Yeah, I wanted to add as well is that, so we do have like, so it's all based on machine learning and AI basically models, and we have patents on that now, like, you know, like it's been demonstrated that it works.
All right. I think that finishes us up. Thank you for all the great questions. Thank you for attending and staying with us through the entire presentation. As these guys said, if you need any other information from us, please send us an email. We look forward to hearing from you. Thank you.
Thanks a lot. And hay season, or like get ready for the new hay season coming up.
Thank you.
Thank you. Bye bye, everyone.
Bye.